My name is Nicholas Krusten, and I am the VP of Product at Plotly. I will be moderating this webinar entitled Operationalize COVID-19 Statistics with Dash, and during which we will talk about a COVID-19 related analytical application developed by our partners at IQT using Dash. By way of agenda, this 1-hour webinar will start off with the speaker introductions and some background info on COVID-19 testing and statistics. Then we will go into the tool itself, discussing the architecture and implementation. And next we'll talk a little bit about Plotly and Dash Enterprise. Finally, we'll have a few minutes for Q&A at the end. For the Q&A, on the right side of your screen, you will see a question box. Feel free to type any questions here during the webinar. The speakers will get to them after the demo and interview. Also worth noting, this webinar will be recorded, so no need to take copious notes. We will share everything afterwards via email. Great. So today's webinar features two staff members at IQT, Tommy Jones and Zigfried Hampel-Arias. I have their bios here on the screen, but let's have them introduce themselves, their organizations, and their roles.
All right, hey guys, just want to confirm you can hear me.
Yep, we can hear you great, Tommy. Go ahead.
Great, thanks, Nick. Yeah, so my name is Tommy. I'm a statistician by training, and I work as a member of the technical staff at In-Q-Tel. Let me introduce In-Q-Tel for the audience really quick. We're often referred to as the venture capital arm of the CIA, and that's accurate, except we're not a venture capitalist, nor are we part of the CIA. What we are is a nonprofit corporation that was founded in partnership with the CIA for the intent of investing in technology startups on behalf of agencies in the U.S. government in the intelligence community. Today we work with several agencies, not just the CIA. As I said, we make investments on their behalf. My role on the technical staff is to help some of the folks on our investment team source companies that we might want to invest in, do some technical diligence to see what the companies do, how they've architected their solutions, and map the company's capabilities to needs of our customers in the intelligence community. And so being a nonprofit, we reinvest the proceeds of our investments into initiatives that are consistent with our nonprofit mission. And one of those initiatives is In-Q-Tel Labs, which my colleague Zig works in, and I'll let him introduce himself and the mission of the labs.
Great, thanks Tommy and Nick. Also, just a quick mic check, y'all can hear me okay?
We can hear you great, Zig, go ahead.
Great, thank you. So I know y'all see my really long name on the screen, but you can refer to me as Zig. And I'm a data scientist within In-Q-Tel Labs. So my background is in astrophysics, but around 2 years ago, I and apparently In-Q-Tel saw what I had learned in my research experience well suited to the work that we do in In-Q-Tel Labs, specifically a lot of heavy lifting, data science and machine learning work. So In-Q-Tel Labs is an open source research lab component of In-Q-Tel, in which we bring together researchers from a variety of disciplines and expertise, and we put those abilities, our abilities, towards a number of hard problems for the common good. We're researchers from computer science, physics, neuroscience, and we're all working at this kind of nice intersection between our government partners that we serve, the startup world, which Chami just referenced, in which we engage, and the academic world of fundamental research. And we identify work on some of the hard problems they face in a number of domains: machine learning, geospatial analytics, cybersecurity, and as we'll see today with bio. And we take those, our learnings, we publish our results, push our code, and build data sets for the open source community to kind of continue pushing the art of the possible.
Thanks, guys. So we're here today to talk about a Dash app that you've released to help people better understand COVID-19 testing statistics. So Tommy, could you give us a bit of background info about that?
Sure. So if right now, if you want to do research on COVID-19 diagnostic tests, of which there are actually literally over 1,000, one place you might want to go is to the FDA's website. The FDA has an emergency use authorization that allows certain tests that with some approval to be able to be put out in the market with something akin to FDA approval, although it's the emergency use authorization that acknowledges, we're in an emergency, you need to move quickly. So you can go to their website, and we've got a screenshot here on the left of a portion of that one web page, and you can scroll down. There's a table listing. I think we're up to about 190 different tests with an EUA approval. But if you want to get more granular information than what's available in this table, you then need to click through one of those links to a PDF, which the title page of one is on the right. You then scroll through the PDF, all of which are formatted very differently to try and figure out the particular piece of information that you need. And if that test isn't doing it for you, or if you're comparing multiple other tests, you sort of need to wash, rinse, and repeat, jumping in and out of these PDFs. That can be a pretty big lift that's kind of frustrating. So we built this application initially in the mind of folks who might be, researchers, scientists who might be looking at these various different tests. How can we make this information more presentable and searchable to them? We did that, and then we also included something that we'll be talking about a little bit more in depth related to performance, which, we've got a couple graphs up here. So when there are actually 4 different types of accuracy, quote unquote, statistics that could be used with any diagnostic test, and you might have heard of some of them. So one is called sensitivity, one's called specificity. Those two tend to be talked about quite a bit, and I'm not going to, bother defining them here, just for the sake of keeping us moving along. But the point is, these are actually characteristics of the test, but they don't answer the type of question that we might care about when we're going to get a diagnostic test. So if I go and get a test and it comes back positive, what I care about is, given the test is positive, what's the likelihood that I actually have this disease? And to do that, we need an accuracy statistic called positive predictive value, and that's what we've got plotted here on the left. Or if the test comes back negative, I would say, well, given that the test is negative, what's the likelihood that I don't have the disease, that I'm disease-free? And to do that, you need negative predictive value, which is plotted there on the right. You might notice that the x-axis of these charts here are plotting something called prevalence. So that's the disease prevalence or the infection rate. And so while sensitivity and specificity are properties of the test, unfortunately, PPV and NPV, the things that we might really care about, are interactions between those properties of the test and the infection rate in the population. And so that's pretty mind-bending, but here's a takeaway from that, which is when we aggregate over lots of people that we're testing, if that population has a very low infection rate or disease prevalence, then the positive predictive value is a little bit lower than what we might like. So if you look at the left-hand side of that left-hand chart, what you'll see is that as the infection rate is really low, PPV is sitting probably around 0.5, which means you got a positive test. If I don't know anything else about you, about whether you have symptoms or anything like that, flip a coin. Maybe you have it, maybe you don't. But as the infection rate gets higher, PPV gets higher as well, very quickly actually, and becomes something that you can just sort of take the test by itself. NPV has sort of a reverse logic of that, which is as the infection rate is low, all else constant, negative tests tend to be pretty reliable and robust on their own. But when you get to a point where there's lots and lots of people infected in the population you're testing, then you start having to be a bit more suspect about negative results. This is actually a property of diagnostic testing in general, not something that is unique to COVID-19 tests. So with that, I'm going to switch to a demonstration of the app that we built, go through some basic functionality before we come back. So bear with me as we probably go through an inelegant sort of screen change here. All right. So what you can see here on this URL, covidtestdb.com, is the attribute browser portion of our app here. So we've got, like I said, just about 190 tests in here. I don't have the exact number in front of me. And these are all ones that have FDA emergency use authorization. And we have focused on molecular tests and antigen tests, but not antibody tests. Reason being, without getting into the testing technologies, we're just not really sure what scientific question the antibody tests for COVID-19 are able to answer. And, guidance around that is, don't use it to diagnose current infection. So we left those off to say, that is something that's still being explored. So just focusing on those two. So we've got a table of these tests here. You can search by company, by test name, you can sort, you can filter, etc. You click on one of these links, which I won't do, but it will take you to the home page of that test from the manufacturer. You can sort or you can filter on the 3 different types of tests. Well, it's 2 different types of tests, but 3 attributes here. So you've got your antigen test, maybe a lab performed test. So is there something where I can take a sample and then ship it out to a lab, or molecular test kit. So if I am a lab, for example, or have all that equipment myself, something that's self-contained that I can get. A lot of these tests, they're compatible with many different types of equipment. It's not a magic box that you just stick some blood or saliva in and it gives you an answer. So if you're looking to purchase a test or do some research, you want a test that's compatible with the equipment that you have. This will send you to a link where, if you can see my mouse here, to the PDF document where we extracted this information. There's different attributes for sample type, et cetera, et cetera. If you click on one of these bars, it brings up some additional metadata like company contact information and things like that. So this is all for folks that if you're doing research on these tests, maybe you're trying to make a purchase decision, that's useful information to you. But if we want to get into some of the performance information, this column all the way on the right will link to the dash portion of our app that focuses on all that performance info. So I'm going to search for the Abbott antigen test here, the second row, and I'm going to click through to the dash application. And so here up at the top, we see a similar image to what I showed you before. We get a 95% confidence interval bracketing this most likely PPV line. We've got the same thing for negative predictive value as we saw before. You can select from all of the tests that we have in the database. Here's all the companies, and then there the tests for that particular company. These are preloaded because I clicked through from the other screen. Scrolling down, we see here this positive result on the left, that is for this particular molecular diagnostic test. On the right, what you'll see is what we've plotted to give some context. So this is clinical test information from a rapid diagnostic test for influenza or the flu. We put that there to give you some context when you're looking at the COVID-19 test of like how well is this performing versus something that is in common usage now for another disease that's much more well understood. What you can see from looking at this is that on the left, we've got basically the same shape as that core curve is between the COVID-19 test and the influenza test, but the confidence interval is a lot bigger on that COVID-19 test. And that's simply a function of, with these emergency use authorizations, companies are moving quickly to get their tests out so that people can use them because tests are needed. And so we often don't have as many observations or as strong of a clinical trial backing up these tests as we might have for something like this influenza diagnostic that was developed over many, many years before being taken to market. Clicking on the negative result here, now we see negative predictive value. That is, again, if the test comes back negative, what is the probability that you actually don't have the disease? In this case, that expected value line performs a little bit better than the influenza test, but same overall shape. They decrease as prevalence increases. And then if we scroll down just a little further, for those that are less mathematically inclined, we've got this text here that says for a given prevalence level, if you were to test 100,000 people, what would we expect to be the number of tests coming back positive? Of those, what would we expect to be false positives or true positives? And then at the very bottom, if I'm a policymaker and I have to think of what is my worst case scenario in this test based on the data we have, we've got that as well. Something that's hopefully in plain English. Now, of course, we don't know what the disease prevalence is in any particular jurisdiction or subpopulation that you might want to test. But we have this slider here where if you can make a good guess, it's going to move. You can see that animation. I'll make a bigger change here. Moves those confidence intervals along the graph where those intersections happen. And now this text has been updated here. Ditto for the negative result as well. And then if you want, you can download the data here that is backing these actual graphics themselves. If you want to do maybe your own analysis or something like that. That's the meat of the demo, but just a couple quick things. I won't click through them. This tab up here that says About Performance will take you to an article that's sort of breaking down in more detail how do accuracy statistics get calculated in diagnostic testing. And then all the way on the right, will take you to another data download link that would let you download the whole data set, or select a specific test, whereas the one on this page just lets you download the one test. So with that, I'm going to switch back to the presentation here. And Nick, I don't know if you have any. Oh wait, before we go to Nick, I had a couple other things I wanted to run you through. Apologies, getting absent-minded in my old age. So if you go to click through the demo or the app, and you start searching through all the tests, you're going to start seeing a lot of pictures of positive and negative predictive value, like what's up here in the slide. Basically, what this means is that a lot of these tests, because they move so quickly, they used small sample sizes, so just 30 positive samples, 30 negative samples, to try and calculate the clinical performance information of the test. Very small sample sizes. What you see here is that these most likely lines are basically at 1 all the way across, which means when they did that, it's perfectly classified everything. Unfortunately, that's often a result of not just the small sample size, but in some cases they use what are called contrived samples, meaning they took a negative tissue or saliva sample and then spiked it with the virus to see if the test would pick it up, rather than directly collecting that sample from a person that they knew had COVID-19. That doesn't mean that this test is bad. It doesn't mean that it's good. What it means is that there's not a ton of supporting data to give us information either way, at least not based on what was reported to the FDA. There are other data sources. One, I can give a shout out to an organization we've worked with a bit called FindDX, based out of Sweden. They've got a database that has independent clinical evaluation data of a lot of these tests as well, and we've just focused on what's been reported to the FDA. And I know you guys, the audience here maybe doesn't care as much about the science or statistics of testing, but maybe more focused on, well, how do you architect this particular application? So what we've got is an Excel spreadsheet that we manually enter information from. So when the FDA gives a new test, or if the information's been updated and we're aware of it, we'll go and enter it into the spreadsheet, which is then actually committed to a GitHub repo. So we've got some version control on it and can roll it back in case someone on the team accidentally fat fingers some of our data. Some ETL scripts written in Go that pull the information out of the Excel spreadsheet and load it into CockroachDB, which is sort of a derivative of a Postgres database. We do statistical calculations in R, and that is calculating sensitivity and specificity based on the data that's been reported in these PDF files, as well as calculating the PPV and NPV, the confidence intervals, all of that. And then those are then plotted in the Plotly portion of this application. And that first part, the attribute browser, is done in JavaScript, where they're both linked together and served up, and you can view them in a web browser. And for future development, we're planning on merging both sides of this application into a single Dash app, but this is still very much in development. And now, Nick, forgive my premature departure before. Any questions for Zig or I about this?
Yeah, thanks for the demo and the architecture overview. So the first question that I would have for you is sort of who is this app intended for, and how is it that you intend for those people to use it?
Yeah, great question. So the core audience of this that we designed it for are scientists or healthcare professionals, people who might be making a purchasing decision for diagnostic testing. So a lot of these folks are, they're either employees of a laboratory that has some of the compatible equipment, and they want to purchase some diagnostic test kits so that they can help test the population around them. You've also got a lot of public health professionals who are buying tests in bulk purchases for their jurisdiction. And then we've even heard of some employers where they are making purchases of their own so that they have tests available for their employees. And so this is the core audience that we designed the application for, but I can imagine there might be some interest from some parties other than that.
Okay, thanks. So from chatting with you a little bit offline, I know that the story of how this app came to be and how it came to be built by you folks over at IQT and IQT Labs is pretty interesting. And I was hoping you could share that story with everyone else here.
Yeah, absolutely. So back in March, when COVID-19 was first kicking off and the whole world, it seems like, went home, what In-Q-Tel did is we stood up 3 internal task forces focused on COVID-19 efforts. So one of our other initiatives that we use the proceeds for that go into this nonprofit mission is an initiative called Be Next. And they're focused on biomedical information and technologies. Given our orientation, a lot of it is oriented towards defense, national security, intelligence applications, but that's staffed by doctors and epidemiologists, biologists, people with public health backgrounds. And they led these 3 task forces, and we staffed them up with folks from all across In-Q-Tel. I was one of them, so being a statistician, even though I was mostly focused on the technology sort of investment side of things, I got put onto our task force for COVID-19 data and statistics. It actually was separate from the testing group. And there's actually a good reason for that. So my background actually does not have really very much biomedical anything in it. My PhD research is focused on natural language processing, for example. But in going to these task force meetings, we were talking about the tests, and at the time, this probably would have been early April, there were a lot of folks that were hopeful that the antibody test could just be administered to every man, woman, and child in the United States, and the people that showed up positive for antibodies could then go out into the world, and so we could, keep the world moving without, at least for the folks that had already been exposed and recovered. And when I was in this conversation, I was like, well, wait a second. I remember something from these various statistics classes that I've heard about around diagnostic testing, where if we do that, the infection rate, if we're doing it across the entire population, will be low, and then maybe like half of our positive tests could be false positives, and that could be really problematic for this proposition. And that led to a lot of internal discussions where I was having to learn a lot about diagnostic testing just to even communicate with my biomedical colleagues while they were, learning about some of the statistical stuff. And, they've had all of these classes. It's not like I was telling them anything new, more that I was, underlining and trying to get them to focus a bit more on the importance of this particular thing. And so that sort of blossomed into me switching teams and us beginning to develop this application together, whereas the attribute browser had already been underway to help folks who might make purchase decisions. This accuracy or performance tool was then added to the development plan.
Yeah, and I just want to underscore, that's kind of when Tommy and the team reached out to me, because again, my background was in physics, and so I don't have this biomed expertise, but as a data scientist, they reached out to me and said, okay, can we put this thing together in a nice way, in a format that's easily accessible to people? And certainly from my point of view, as a data scientist, that's one of the most important tasks of my work, is conveying that work in a cogent manner to a number of different audiences. Now, of course, like the domain experts are probably the easiest to target and explain, like, oh, this is what this means, and this is the consequences of what this means. But if you want to reach those larger audiences, you got to get people interested in and make it digestible for the importance of the work that we do. So it has to be done in an accessible way. So building this app was quite a demonstrable way of facilitating or like bridging that gap between the data itself, the data scientists and the domain experts, and in this case, even more importantly, those who happen to be policymakers and the bio folks, those that really need to have actionable insights from this.
Thanks. Yeah, that really is a very interesting story of how this came to be. So could you tell us a little bit about your experience in building an app like this using Dash?
Yeah, definitely. Well, I should state that the foundation for the app, like the main components, were built rather quickly, and that was actually quite a surprise to me. I wasn't necessarily expecting that, given my past experience in kind of conveying results in an accessible manner. So I used to give a lot of PowerPoints and build even my own analysis web pages and like HTML. When I present my results, it's just to make it, at least put it out there for my colleagues. They could kind of go and look and see what I was doing, but there was always something lacking from that. First of all, the PowerPoints were always like tailored for each presentation. The websites were always really difficult to, like clunky to build and maintain. And anything new, any new results required new code and updates. And so it would usually take me a week or two to get things to where I kind of wanted them to display that information effectively. But when the testing team reached out to me and said, "Can you build this thing?" I spun up Plotly Dash, And I was able to flesh out the main components of this, the main parts, in like a weekend timescale. Just putting all the data, the text, most of it was there pretty quickly, and after that, it was just lots of tweaking. And I think a lot of that was due to, there were a couple components that kind of helped that. The first was the multitude of just freely available examples online was a big help to me. I had never used Plotly Dash before, but it really facilitated me going from zero to, hey, we've got something that's presenting what we wanted to do. The fact that it was in Python was great for me, since a lot of my research experience, the coding's been done in Python. And that also includes the analysis components. So like actually doing calculations, which meant that, propping up things, I could simply use the code, the analysis code that I was using to plot things, to run numbers in the app itself. And that's what you see live. So it was much easier than building out like HTML tables in PHP with a bunch of matplotlib figures that I'd always have to kind of regenerate. I think what's more, and really important for these kind of applications, and for what I mentioned earlier about communication, was that it's interactive. You can move that prevalence slider around and get a sense of how things change live. And I feel like, from my perspective, again, it's that ability to make the app interactive, which really encodes that sense of trust that we need, certainly us as researchers, such as myself, to build with the decision makers, and in this case, again, the public health professionals. Again, it's super important for that communication, and certainly given the current state in which we find ourselves. So I love that, the work that I've done can be kind of validated or verified live for other folks within the app itself.
Great, thanks, Zig. I'm really glad to hear that that building with Dash was such a great experience. So in terms of the future of this app, can you tell us a little bit about where it's going, what's next? I know that the app is open source. Can you tell us a little bit about your plans there?
Sure. So as we've mentioned a few times, In-Q-Tel Labs, we are an open source lab. And so the work that we do, we aim to go back to the community. Again, I mentioned earlier the code that we push, the results that we get, and the data sets, that all goes out into the public domain. And so that also means that we want others in the community to engage with In-Q-Tel Labs, because our whole goal is, we want to make things better, and we can do these things better together. Tommy, do you have anything to add to that?
Yeah, I mean, just thinking about the open source aspect of this, I think we would really like for folks to, fork this, submit pull requests, open issues. This is still very much in live development, and we want to make it as useful to the people who are interested in it and actually using it, whether it's our intended audience or not, as possible.
Great. So we've just pasted the link to the GitHub repo here in the chat, in case people are just dying to click on it, and it'll be included in the email that we send out along with a video of this webinar for reference, in case folks were really anxious to find out more about that. Is there anything that we can help you do to help raise awareness of this app above and beyond this webinar, or that folks on this webinar can do to help?
Yeah, I mean, I would say, check the app out yourself, share it with anyone that you think might be interested, whether they're in our targeted audience or not. I know that, Nick, we had discussed offline, what about individuals? So maybe I'm not a public health professional, or I'm not planning on purchasing tests. Would this be interesting to me? And, maybe. If you're aware of what tests are being used in your local jurisdiction, your town, your county, whatever, you can go look them up to get a little bit more information about them. And like I said, the performance information is the data behind it's a little touch and go. But if you get a test and you say, hey, it doesn't look like there's a ton of performance data here, I think that's a very legitimate question to be asking as a member of the public. What's gone into the decision to use a particular test or another? Do we have better data either from some of that independent stuff that FindDX is working on? And we are planning to incorporate those data into the app in a future iteration. Or was this just we grabbed what was available? I mean, I think as an individual, using this to say this test will perform this well, I'm not sure the data can fully support that, but using it to ask questions about what's going on where you live and with your public officials, I think is a pretty useful aspect of this as well. So even if you or your friends aren't part of our target audience, if you're interested, check it out, give us feedback, and we would love to have it.
Yeah, and I just wanted to add to what Tommy said. If there are professionals out there who see a need for something, some other calculation or display that would be useful to them, open an issue. Tell us what would be useful, or put in a pull request, write the code, and we'll incorporate it if it's really valuable. We built it as this very flexible thing, so we can add things that would benefit those who need it.
All right, thanks guys. So I'll talk a little bit about Plotly and Dash Enterprise for a few minutes, and then we'll open it up to Q&A from the audience. So I would encourage anyone in the audience who has a question to please type it into the little question box, and I'll sort of sift through them and ask Tommy and Zig sort of collated set of questions. But a few words about Plotly before we get into that. We were founded in 2013 by graduates of Harvard, Stanford, and McGill, and we're an open core company. Our open source libraries have been downloaded more than 4 million times a month, putting them in the top 0.02% of GitHub projects globally. Plotly has raised over $25 million from investors such as NVIDIA, Real Ventures, VanEdge, and of course IQT. And we're proud to have Dash Enterprise customers in every major data intensive industry that you can see on the right-hand side. They're including banks, insurance companies, airlines, power utilities, manufacturers and retailers, government agencies, and even sports teams. Our customers use Dash Enterprise to build applications enabling them to optimize projects from transportation routes to drilling plans, to use natural language processing to analyze customer interactions, to use predictive models to plan for the future, to do anomaly detection, clustering, to respond to changing situations in their business, and of course, as we saw with this app, to connect sort of statistics and data experts to domain experts around an interactive analytical application. Next slide, please, Tommy. So the app that Tommy and Zig told us about today was built with the open source Dash data visualization and user interface toolkit. Dash works with the industry-leading programming languages for data science, which are Python, R, and Julia, and is free to download and use. It's the most popular framework for creating analytical applications in Python, with over 300,000 downloads per month. AI researchers around the world have standardized on Python, R, and Julia as the languages they use to develop leading-edge technologies and models. And Dash enables data scientists to directly use these models. And furthermore, these rich open source ecosystems guarantee that Dash applications can connect to any data source, from SQL databases of any flavor, such as CockroachDB in this case, to the all the way up to the latest unstructured cloud storage frameworks. Dash Enterprise, on the other hand, is the commercial platform that Plotly has built around this open source core. Dash Enterprise is a platform for operationalizing AI within the enterprise. It includes an on-premise, customer-hosted, Kubernetes-powered server product for deploying Dash applications, as well as professional services and training to make data scientists productive as fast as possible. Next slide, please. So the open source Dash toolkit provides the core UI layer of an analytical app, like we saw today. And Dash Enterprise basically provides the rest of what we call the enterprise analytical application stack. This includes a deployment server, as I mentioned, with built-in authentication and authorization that connects directly to existing enterprise infrastructure to make sure that only the right people can see the right things. It includes a professional-grade styling and branding design kit so that data scientists can focus on function and not form. The built-in snapshot engine allows users to save application views as shareable links or print-ready PDFs. Dash Enterprise also comes with ready-to-go template applications that implement advanced application patterns such as data connections and task queues to manage jobs running on distributed clusters. Dash Enterprise supports software development best practices such as continuous integration and continuous deployment. Dash applications can implement scheduled checks that can send alerts or reports to stakeholders as data streams evolve. And finally, Dash Enterprise includes user analytics for every app, enabling data scientists to validate that their app is being used and delivering the business value that their job entails. To sum up, Dash Enterprise includes everything a data science team needs to build analytical applications without needing to hand off their project to a separate full stack team of front-end and back-end developers. This results in faster delivery and better outcomes because apps based on models are developed by those who know the model best. So if you're interested in Dash Enterprise, we will be following up via email with ways for you to talk to our sales team or ask any further questions. But at this point, I'd like to open up the floor to some questions from the audience. We've got a couple accumulated here. Please feel free to keep asking questions as these answers sort of raise additional ones. So we've got a really good question here. How receptive have end users been to displaying data in this format? Have you been able to get feedback on the intuitiveness of the display? And has it changed how you designed the tool?
I guess the short answer to all of those questions is yes. One thing that we have as an open issue, but have not done yet, so part of our development here is to display some of the underlying statistics and data related to sensitivity, specificity, sample size, alongside the PPV and NPV calculations. By and large, I think the reception of the way we've displayed the data has been surprisingly positive to me, especially when we displayed it to a lot of those biomedical professionals who, like I said, they live, sleep, eat, and breathe this stuff. Interestingly, they had not seen the information displayed this way before, where it was like the whole curve of performance. Instead, it was much more traditional sort of application of, assume a performance level, calculate one PPV and NPV, and then move on. And so the way that they were able to see all of it and interact with it, we've heard has been pretty useful. Another thing that was pleasing to me to hear specifically, we had somebody the other day in a public policy role say that they appreciated the text underneath the graphic because it helped them talk policymakers through what some of the implications might be, particularly that last little paragraph about the worst case scenario, because that's often how policymakers want to think and design policy. Zig, did you have anything to add there?
Nope, I didn't have anything to add.
Okay, thanks. The next question basically revolves around how would you characterize the skills required to build this kind of Dash application? Do you need someone with a computer science background, or Zig, I guess maybe you can speak to how would you characterize the skills required to build this kind of thing?
Sure. I think so. Just to give you a sense, our team was on the order of like 10 people or so. But your question was more to develop the application. I don't think you would need a computer science background to necessarily build an app as we've demonstrated today. Um, we do have computer scientists on our team, and they did help us build various components of the database, for example. But strictly speaking, to actually kind of display this stuff the way we've done with a smaller amount of data, no, you don't need a CS background to build out an app like this in Plotly Dash. You would need to have a good understanding of Python for sure, and being able to put those components together. But kind of as I mentioned earlier, I think one of the greatest resources available is the examples that are online. So if you want to put in a map that you go and click on a specific city and get a sense of the details in that specific GPS location or something, there are examples that can help you do that. You don't have to invent the wheel. As I discussed earlier, I would always be reinventing my web pages for a specific analysis. Here, you can go and find those examples online, and it really sped up things to get from, hey, I've never used this before. Oh, here are some examples. Great, we've got something working for us.
Awesome, thank you. We've got a question here around the specific Dash components that were used. So I guess can you confirm that the app that we're looking at here uses just the built-in stock Dash core components, or did you use any additional Dash components for building this app?
No, it should all just be core components and Bootstrap stuff. So just anything that had to do with building various tables, the core components themselves, HTML components for some details, and of course the Bootstrap components just to kind of facilitate building things out so that I wouldn't have to get into the nitty gritty. So that really made things very easy to display text, to position all of our graphics, and of course the slider, which is great. I love it, and the animation too. I think that now, I believe that most up-to-date version, you move the slider or you change between the figures or change between the data sets, the tests, and the graphics should animate, which I think was a nice little touch, like a cherry on top.
Oh yes, as the head of graphing libraries here at Plotly, that did not escape me. I appreciated that also. So you mentioned bridging the gap between domain experts and business users. I guess, do you have any recommendations for folks listening on how they might do that within their organization beyond looking just at the domain specific here, which is COVID-19 testing? Is there anything that you could take from what you've learned here and provide sort of as a recommendation for listeners about how they can achieve success in this sort of critical domain within their organization?
Yeah, if I can share my thoughts sort of on the trials and tribulations of taking what was in my sort of like cold analytical statistician's brain and communicating it to the doctors and biologists I was working with. I'd sum it up with show, don't tell. And truth be told, this app was an app because I think I felt I'd sort of hit a wall with the team in terms of being able to explain what it was that I meant and really getting it to sort of sink in, which isn't to malign our team at all. These are brilliant people. It's just you have to get people's attention. And so show, don't tell turned into me plotting a couple things and vigorously pointing at them that looked a lot like the PPV and NPV graphs with the confidence intervals, and drawing lines over it and things like that to talk them through it. And that actually is what caused us to say, hey, this would make a good application. And so I think when you're having that sort of those sorts of friction of communication there, being able to put something up graphically to make your point is often a lot easier for people to digest. Like they can digest more information faster than talking to them or writing memos, which was my first approach to all of this.
I want to add on to what Tommy said too. Frequently what can happen is experts from two different fields or domains can be saying the same thing, but not understanding each other. They might be using different language. And that also, of course, goes visually as well. I certainly, just as Tommy mentioned, the graphical information that's provided with these curves there's a lot there, but that's how I have been trained and learned to access that information. And just below it, as Tommy showed in the demo, is something that spells out exactly what needs to be taken away. And that just feeds into precisely what he mentioned, the show. Make it very clear what it is that needs to be taken away. Even if all that information is there, make it very clear that this is the tidbit that you need to be successful or have a good outcome in whatever it is your task is.
Yeah, that's always a critical thing when building an application, especially one meant to sort of reach as an audience, a broad audience, is to sort of repeat the same message in multiple different ways. So some people might lock into the graph, some people might lock in more into the text, some people might sort of look at one and then the other. And so I think that's one of the great strengths of this app, is that it really uses both visuals and text in this sort of interactive way to reinforce the message. So well done, guys. We've got a question here about sort of the big data aspect here. So can you maybe speak a little bit to the size of data that's in this app, and how you thought about how the size of the data would relate to the architecture of the app?
I can speak briefly about the details. So the actual total size of the data that we have there is something on the order of like tens of megabytes or something. So it's not a massive database. Of course, there's lots of room to grow, but the way that we initially built it was actually slow, how we accessed each of the tests. And so that did feed into how we interactively pull out that data so that it's visualized in the graphs. So but that was more of a data packaging issue, and a little bit of how we accessed it within the app. So I couldn't speak of a specific limit, because we can actually just continue to add on to this with no additional lag time or issues accessing that data as it is. If it was some massive, say, gigabyte or terabyte scale database, then yes, we certainly wouldn't be hosting it all on GitHub. That would be the first issue. But then that would definitely inform how we structure accessing that data. Tommy, do you have anything else you'd like to add to that?
Maybe just like a little detail. I mean, the core data, of course, is like I said, if it's like 190 tests, that's one table that's 190 rows. But then when you blow it up to that, what goes into each one of those charts, we ended up with, I think, something that was like 36,000 rows and growing, which still is not big data per se, but when you get to about that size, you need to think a bit about the architecture and how the application accesses it, for sure.
Definitely. So I think we have time for probably one last question. You mentioned a few times that certain things are still in development. So maybe can you give us a little sneak peek of what's coming down in the very next phase of this app? Is there a new feature coming up? Or I know you mentioned that you wanted to merge the two aspects of the front end into one Dash application. Is there a particular sort of timeline or plan for that?
Yeah, I think the three biggest sort of changes that are in my mind right now are, one, there's the merging of the two applications into one. We're actively working on that. There's some back end stuff that we're rejiggering to try and automate some of the updates that is a precursor to that. No hard timeline. That's one. Two is then incorporating the data from FindDX. One of the pieces of feedback that we got from some public health professionals was, it's all fine and good to say that this is the data that's being reported to the FDA, but where there's better data out there, that can be more illuminating to people. I think it's just that we don't want to be in the business of saying this study's good and this study's bad. So folding in that additional find data will then let you, for one test, see multiple different trials on it if that's available. So that's the second one. And then the third is reporting some of those sensitivity, specificity, sample size alongside the PPV and NPV graphics, because just one, we got that feedback, but two, for me as a statistician, one of the things that I really like about the way we've plotted this and it's interactive is that you can get more of an intuitive feel about like what's going on with the numbers and the likelihoods underneath the hood. And so by explicitly putting sample size, sensitivity, specificity, you can see sort of how these things interact with each other as you're looking at the graph and playing with that slider.
Okay, thanks for that. So I think we're just about at time, and I'd like to thank both Tommy and Zig for sharing this with us. And as I mentioned before, we'll be following up via email with links to the open source code, the live app, the recording, and we encourage everyone to sort of check out the app, publicize it to anybody who feels like it might be who you feel it might be useful for their work or their life. And if you feel moved to contribute to the development of this app, please do get in touch with the team, file issues. We really look forward to seeing sort of what comes out of that. So thanks very much, everyone, and we'll see you next time.
Thanks for having us.
Thanks, Nick. Bye.